sample has 45, sample size is 45, and we determine the mean, and we repeat the experiment many times. So we draw many samples of 45, we determine the sample mean for each. What is the probability that one of them that we select will have the mean less than 60,000? And the probability is 1.8%, roughly. 1.8%. Okay, where we are here, so let me stop sharing. I meant to share. Okay, round to 4 decimal places as needed. The probability that the mean salary of the sample is less than 60,000 will be, where's my keyboard? I have a keyboard. Okay, so it's 0.0180. Round to 4 decimal places. Let me look again and see what was the fifth. The fifth decimal was 2, so that's okay. So I'm going to check the answer. Any questions? Any questions?
No. Number 4?
Okay, number 4.
Oh.
Did you have a question about this one? Anyone? Okay. Oh, I haven't completed. Okay, sorry. Interpret the results. Choose the correct answer below. Only 1.8% of the sample of 45 specialists will have a mean salary less than 60. This is an unusual event. About 18%, that's not, about only 18%, about 1.8 of samples 45 will have a mean salary less than. This is not an unusual, this is an unusual 1.8. So obviously a B and C have nothing to do with anything. This is not, we're not talking about 18%. This is 1.8%. But now we have to decide only 1.8% of samples of 45 specialists will have a mean salary less than. This is an unusual event. And about 1.8% of samples of 45 specialists will have a mean salary less than 60,000. And this is not an unusual event. To me, a 1.8% is an unusual event.
Yeah, I'm not sure I understand the rationale there.
Anything that, what I would say, it's a very good question. Anything that it's roughly less than 5%, roughly, I would consider it unusual. If it only happens about 5% of the time, it's not an event that happens frequently. And this situation is 1.8%. Now you can say 1.8%, it's still large. But I'm inclined to so for example, the previous situation was 0.2%. Now if you compare 0.2% with 1.8%, then 0.2% is much lower, right? It's 9 times lower, actually, than 1.8%. So can a sample, if the sample is, so before we choose, let's stop sharing for a second. And the best way is to make some calculations. I just had to take the keyboard away. It's a very good question. So remember X bar, I'm just copying from there, is normal, of course, with 62,000 and 6,400 over the square root of 45. So here is 62,000. And I would like to see to use the empirical rule, right? So this, if you remember, this is 68%. This area is 95%. And this area is roughly 99.7, right? So I would consider that anything that is outside of the 95%, like here in the tails, we're going to talk about tails a lot in the next chapters. So this area in the tails, right, below this or above this, I would consider it unusual. So it's going to be mu plus or minus 2 sigma. But sigma of the x bar. And I guarantee you that this will not include the 60,000 because of this percentage. So let's calculate it. We have 62,000 plus or minus twice 6,400 over the square root of 45. And I'm going to put this in the calculator and find the interval, this interval. So 62,000 minus 2 multiplied by 6,400 and divide this by the square root of 45. So this is 60091, barely, or 92, but still above 60,000. And this one will be the same thing but with plus 63,908. So this is the middle 95%. Any questions? Now, if you want to determine the 99.7%, we can do that too. Then it will include it. So all I have to do is just change the 2 into a 3. So mu sub x plus or minus 3, the standard deviation, will be, the upper bound will be 64862, and the lower bound will be 59138. So 3 standard deviations above the mean, plus or minus, then this will be 99.7%. And this will include the 60,000. See, the 60,000 that we are talking about is included here. But it's not included here. You can say barely, but it's not. So we have to make a conclusion. If you're thinking about 95%, then you'll say it's unusual. If you are very strict and if you are thinking, no, I want 99.7%, then you will say it's not unusual because it's included in the interval. Any questions on the analysis? Any questions? So we consider 99.7, then it's not unusual.
So the answer would be A. I forget which one that it's supposed to be.
I would personally consider that it is an unusual because it's not within 95%, and the probability is small, smaller than 5%. So that's what I'm going to put in, as we discussed it from the beginning. Oh, I'm not sharing? Sorry. Yep. So this is an unusual event. The probability is 1.8%, and it's outside of the most usual. The most usual is 95%, but it's outside of 95%. You can say barely, but it is out of the 95%. Yes, Sean, I'm sorry.
So we're in agreement that it's unusual then.
It is unusual. That's
Okay.
what I've been saying from all along, because the probability is less than 5% roughly. It's actually less than 2.5% to be exact. Right? So I'm going to stop sharing for a second. So if this is the 95%, this tail has 2.5%. So anything that is less than 2.5% or above here with 2.5%, I will consider it unusual. Yes. It's outside of the middle 95%. So this is 0, this is 2.5%, this is 50%, this is 95% plus 2.5, 97.5, and this is 100%. So it's this in the tail area of less than 2.5%. So I will consider it unusual. I love these discussions. Okay. Back to, oh, I wasn't sharing, sorry. So let's take a look. Anything else? Oh, I think you said, was it problem 4?
Yeah, I think we had question 4. In the
Question
queue.
4, very good. The more variable the data, the accurate the sample mean will be as an estimate of the population mean. Sample mean of the population. Find it, fill in the more variable. So the more variable the data, the less accurate the sample mean will be an estimate. So the more variable, the more dispersed the data, the less accurate the sample mean will be as an estimate of the population mean. Let's think. So the more variable the data, the less accurate I would say the sample mean will be as an estimate of the population mean. That's my assessment of this answer. Let's see. Okay. The more data we have all over the place and not clustered together, the less accurate the mean that we get from the sample will be as an estimate of the population. If it's all over the place, it's difficult to determine a good estimate. Good. Very good pick. Thank you. I don't know how to show you these problems. I don't know how to click on, I don't think it allows me to click on any particular so we can see and choose after we see them. So, but that's okay.
You
Good.
can always just go through them and find one that you like or would like to give an explanation on.
Oh, yeah. I mean, I can click on all of them. But I don't know if it allows me to move on after unless I enter an answer.
No, you're able to move on. You're able to see all of them without giving input.
And for some reason, okay. Is the distribution of all values of the statistic, blah, 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 is the distribution of all values of the statistic when all possible samples of the sample size n are taken? Yes. So this must be the sampling distribution of x bar. Okay, or the sampling distribution of a statistic. The sampling distribution of a statistic is a distribution of all values of the statistic when all possible samples of the sample size n are taken. So the uniform distribution, no. The standard normal, no. The normal distribution, no. It's the sampling distribution of a statistic. Is the distribution of all values of the statistic when all possible samples of the sample size n are taken from the same population. Any questions on this? Oh, you actually asked me to click on them, not to solve anything. Okay. Sorry. Do we want to look at this one? Is the statement below true or false? The distribution of the sample mean x bar will be normally distributed if the sample is obtained from a population that is normally distributed, regardless will be yes, regardless of the sample size. Yes, this is true. So x bar will always be normal. regardless of the sample size. Yes, but the higher the sample size, the closer to the normal. Will be normally distributed if the sample size obtained from a population that is normally distributed regardless. Yes, true. The larger the sample, the accurate the sample mean will be as an estimate. Yes, the more. So the larger the sample, the more accurate the sample mean will be as an estimate of the population mean. True. The more variable the data, I think we did this one, right? 4. Yeah, we did it. 5. The standard deviation of the sample distribution of x bar, denoted x sigma x bar, is called the standard error of the mean. It's called the standard error of the mean. And I think we did 6. I remember doing 6. Yeah, it's already there. Determine mu. I don't have to determine mu. It's 71. It's the same with the distribution mu. So I check. Okay. And I think it gives me something else now. Yes. And this is it's 14 over the square root of 49, which I know is 7. So 14 over 7 will be, anyone?
14?
14 over 7, because it's the square root of 49. So 14 over 7. 2?
2.
Very good. 2 it is. Use the central limit theorem to find the mean and standard error of the mean if the indicated sample of the indicated sample. Okay. To sketch a graph of the sampling distribution. Then sketch. Okay. The per capita consumption of red meat by people in a country in a recent year was normally distributed. I have to take notes. Normally distributed. So this is X. It's not X bar yet. So this is X, normally distributed with a mean of 118 and a standard deviation of, is it 39.2? I see. Correct me if I'm wrong. Random samples of sizes 18 are drawn from this population and the mean of each sample is determined. Okay, what is the mean? Say it again.
You're still sharing. We can't see what you wrote down.
Oh, I just, yeah, let me show you what I wrote down. I just copied the information. X is normally distributed 118, 39.2, comma 39.2, and n equals 18. I just copied the information was given to us. Okay, so then, what is the mean of X bar? Anyone? Anyone? Anyone would like to tell us the mean? 118 is the mean of the population, always. And now the standard deviation, round to 3 decimal places. What will you divide? You will divide 39.2 by the square root of 18. So I got 9. 9 point, it says 3 decimal places. 239, but then it's 5, so it's 240. Oh, so what press continue to see more. Okay, very good. So now, let's see what they want next. Sketch a graph of the sampling distribution of X bar. Choose the correct graph. Okay, so I have to choose a graph that has 118 in the middle. I cannot choose B. I cannot choose D. Those are out of question. So I'm focusing on A or C. So I look at A, and I know that, let me zoom in. Okay, so I know that this distribution should have 95% roughly between 99.5 and 136.5. Then I'm looking at C for a second. So it does have 118, so I have to calculate plus or minus 1 standard deviation from the mean, plus or minus 2 standard deviation from the mean, actually. So I'm going to stop sharing. I'm going to copy my information. X bar is normally distributed 118, comma, 9.24. I'll stop sharing right now. Okay, so we want to determine X bar, which is 118, plus or minus twice multiplied by 9.24, and see the interval. I'll put in the graphing calculator. 118 plus 2 multiplied by 9.24, and the other one with minus. So it should be somewhere between 99.52 and 1.36, 136.5. Now, if I calculate 118 plus or minus 3 times 9.24, I will get, changing the signs there. So I would get 90.28, comma, 145.72. Okay, now I go back to our graphs. I'm going to share. Is this clear what I'm doing here? I'm trying to determine which one is the correct sampling distribution of X bar. So this one is between 99 and 136. And this one is between 90.28 roughly and 145.7. So I'm assuming since this is so close to including everything, I will choose C. C should have included everything plus or minus 3 standard deviations. This one only has 2 standard deviations included. But this one shows 3 standard deviations. So I will choose graph C. So I'll click on C and see what they say. So that's the way of looking at a graph and identifying which one is represents the sampling distribution of X bar. I meant to create a quiz for today, but I didn't. So we will have 2 questions then on Monday.